Good morning, everyone. I'm Naavind Balan from FKTE Unimap RY31. Today I'm going to present about the Lab 2 operational amplifier. I already constructed the circuit, but for the presentation and demonstration, to demonstrate the circuit, so I already set the value, and then I just going to replace it where I'm supposed to be put the resistor and the amplifier and the power supply. So these are the operational amplifier to get the output value, and then this one is the inverting, and then this one is not inverting, but the circuit I'm doing now is inverting, so the supply should be on the top, and it should be at the negative terminal. So then this one R1 resistor and my RF resistor are supposed to be RF. I just put as R2, and then uh, I have the power supply. I have the power supply source to the negative. So this one should be here, then this one be here, then my amplifier, then my power supply. So once I completed this, I just need to go to the I already done the edit simulations command. I get run 10 milli, and then the file I'm searching for, this one I can't get it, so I download from the Google, and then the file name is I already mentioned over here, and then the part number also ILM741 in my library. So if I run this, my V in should be this one, and my V out it's like this, cause it is an inverting amplifier. So I get the saturation point, and then the waveform should be in the opposite directions. Why the waveform is in the opposite direction? Because of that inverting amplifier, because supply is in the negative connections. So if this one is on the top, and then this one should start from the bottom. This one is for the experiment to inverting amplifier. Okay, this is my first circuit, and then for my second circuit, this one is my second circuit, the inverting amplifier. So I already put my values, then my amplifier, power source, and then this one is the connections of VCC. I just do a separate one, because if I put over here, it's like a messy place, and then I can't show you the proper connections under this. So the VCC should be over here, and then the VCE connection is over here, so that this supply will be contribute over here, and then this one, the positive terminal is connected to the V in. So if it's connected to the V in, it should be non-inverting amplifier. So this one also I already done the edit simulation for the 10 milli, and then my library for the amplifier, and then if I run this, I get my V in is this one, and then my V out should be like same, but the value will be different, because the connections over here is just 1 volt, and then over here is 15 volt. the connection is 15 volt. If we go inside and then go this side to get that V out should be more than the value V in. So the V in is just 1 volt, then the V out for the V passing the RF should be 15. So the resistor will be deduct some thing, then the output should be 12 volt. But it's just same waveform as the V in, but it will be more than, or it will be triple for, it will be more than the V in for my second amplifier circuit. So now I'm going to do the summing amplifier. So the summing amplifier also the same case. I already key in my value for the source because I'm finding for a sine wave, and then the power source is the same one, 15 volt, and then negative 15 volt connected to the operational amplifier circuit. So this one is a summing amplifier. So a summing amplifier is to make it a short one and a simple V out. So once I run this, I will get my V in is this one, 0, starting from 0 to 1 volt. That means this one is a 1 volt, and then my V out is 10 volt because my power supply is 15 volt. But when it's passing through the amplifier, it will be less a bit to get the proper V out. So my V out value will be 10 volt, but it will be like the waveform like a inverting. That means this one will be in the positive, and then next it go to the negative. But for the V out, starting from negative to the positive waveform. Okay, integrator. For the integrator circuit, they already have a capacitance, uh, resistance, and then the power supply, and of course, operational amplifier. For this one, how to know that it is an integrator? On the integrator circuit, there will be capacitor on the near the RF circuit, but my RF I just put as R2, and then the value of RF is 10 mega. It's quite high, so the value will be like, so my first waveform is will be as square waveform because I need a pulse. It will be in, like it's act as a switch also. It will be on and then off for the some period time. First it will be on and then off, on, off, on for the V in, and then for the V out it will be like, first it will be going down and then going up as a triangle shape because it is act as a switch. So if like a switch, once we press on and then it just suddenly strike, and then if we want to off, it will suddenly going down, sudden change, so that the power will be immediately off and on. Then the value for the input is 1 volt, and then the value for the output, crossing for the value for the op amp is 15 volt, and then it by crossing the capacitance and the mega resistance that is 10 mega will be the 14.1 volt. And the final circuit is the differentiator. For the differentiator, the capacitor will be on the near the V in, so that we will know it is an differentiator. And different to how find the differentiator circuit, the capacitance will be in the front, and it will be on the top also, but the crossing the RF is our F will be here, and then the capacitance will be in front of the RF. So the value that I put for the power supply is 15 volt, and then my AC source to get the power pulse waveform is 1 volt. So the simulation from the circuit is this one, the triangle shape, and then for the output will be in the square wave. It shows that it's got some sudden change point over here. If we press on, first it will be accelerate, and then will be decelerate. So when it will accelerate is sudden on, this output will be a bit of shaky points, but it will turn it off. But once we on, and then it will be show as on power supply. So the connections is this one for the differentiator. Thank you so much.